Welcome back, guys. Today's video is going to be on the concept of ionization energy. So ionization energy is the amount of energy it takes to remove an electron from an atom. So to help us understand this, let's look at this example right here. So if we see atom X, which can stand for any atom on the periodic table, what we notice is it doesn't have a charge to start off with, right? If an atom doesn't have a charge to start off with, that means it has an even number of protons as electrons, right? Protons carry a positive 1 charge, electrons carry a negative 1 charge. When you have an equal amount of them, they cancel out. So atom X is here with its neutral charge. And so when we remove an electron from atom X or ionize it, right? So we see ionization energy. When you ionize an atom, that means you are taking away an electron from that atom. So we take away the electron. Now atom X is left with that positive 1 charge. You did not change the amount of protons it had. You took away one of the electrons. You now have one more proton than you do electrons. Now you have a positive charge, right? So we successfully ionized atom X. Now, why does that take a positive amount of energy to do, right? This is ionization energy. So we must have put in an amount of energy, I should say, to complete this process, right? So let's look at lithium to better understand why it takes energy to do this. So we see the lithium. It has 3 of these positive charges in the nucleus of its atom, right? Now, why is that? Well, lithium is number 3 on the periodic table. That means its atomic number is 3. That means it has 3 protons, right? And it's important to note that protons hang out in this nucleus of the atom, or the very center of the atom. Now, every atom on the periodic table, before it has a charge, before you start messing with the amount of electrons that it has, is going to have a neutral charge, right? So if it has 3 protons, it's also going to have 3 electrons. Now, if we want to repeat the process that we did up here, what we can do is we can say, okay, well, let's take lithium and let's remove one of these electrons, right? So that is going to be ionizing lithium, right? That's what you're going to do when you want to ionize lithium. Now, why does that take energy to do so? So let's put this electron back and see why it takes energy to complete that process. Well, we know that positives and negatives attract, right? We have these positively charged protons and these negatively charged electrons, and they actually want to attract because positives and negatives attract, right? So this electron doesn't want to leave this lithium atom. It's attracted to that positively charged nucleus of the atom. So if you want to come take away that electron and rip it away from that positive charge, you're going to have to put in a positive amount of energy to come rip away that electron from that positively charged nucleus that it wants to hang out near, right? Because they attract. So we have to come put in an amount of energy to come rip away that electron and take it away and successfully ionize it. Now, let's put that electron back and let's analyze some of this data over here on the left. Now, this is a common way you'll see the ionization energy written, right? You'll see either in a table, ionization energies for a certain atom, right? So what does this data mean? So we have IE1, IE2, and IE3. Now, IE stands for ionization energy, right? And why are there 3 of them? Well, for every atom, right, there's going to be a certain amount of electrons. This atom has 3, so there are 3 ionization energies, meaning there's a specific amount of energy it takes to remove each one of these electrons. Now, if you're dealing with an atom that has 7 electrons, there would be 7 ionization energies that go through and give you a specific amount of energy it takes to remove each one of those 7 electrons. So we look at this table and we see, okay, ionization energy 1 is 0.6 attajoules. Now, what does this mean here? Now, joules are the unit of measurement for energy, right? So if you say that something takes energy, we're going to measure that in joules. Now, attajoules, right? So this A stands for atto, right? Is just a prefix. And we know that 1 times 10 to the negative 18 joules is in 1 attajoule, right? So we're measuring that in attajoules, and we're seeing that 0.86 attajoules is required to come remove this electron over here. Now, it's really important that you watch my next video on valence electrons and how to set up an atom in the way that I have right here in these shells with 2 electrons here and 1 electron here. So I'm going to go over valence electrons and what those mean and how to set these up. In this video, I just want to cover what ionization energy means and why it takes energy to remove them, but it's important that you watch that next video to see why we're removing the electrons that we are in the order that we are. So make sure you watch that video. So we have ionization energy 1. So that means that we are going to require, it's going to require 0.86 attajoules of energy to come rip this electron away. And remember, we're putting in energy because it wants to hang out near those positively charged protons. Ionization energy 2 is saying it's going to take 12.1 attajoules to come remove this second electron. And ionization energy 3, it takes 19.6 attajoules to come rip away this third electron. So if we look over here at these practice problems, it says, why does it take energy to remove an electron from an atom? So why does it take energy, right? We have to put in a positive amount of energy to rip an electron away from an atom because the nucleus of every atom has those positively charged protons. They attract those electrons. So to actually get rid of that attraction and rip away an electron from it, you're going to have to put in a positive amount of energy to do so. So that's the answer to number 1. Number 2, how many ionization energies does carbon have? Well, carbon is number 6 on the periodic table. That means it has 6 protons, 6 electrons. So if we're counting how many ionization energies it would have 6 ionization energies, right? A specific amount of energy it's going to take to remove each subsequent electron from that carbon atom. So just as a summary, we have ionization energy, right? We're removing electrons from atoms. And remember, it's going to take a positive amount of energy to do so. And we can actually measure the amount of energy it takes to remove each electron from that atom. Thank you for watching, and make sure to check out my video on valence electrons so we can better understand this process and have an idea of why it takes a certain amount of energy to remove each subsequent electron.